Okay, so now we know there's only one answer, and at least some of the groups are still hunting for it, and the groups that have found it have plenty of other questions to work on. So let's spend a few more minutes trying to find that final number.
So I think the real question is if you can describe that number and
an output number. So you do the biggest and smallest.
whatever you get in the end. So you plug all
Next
the
to
way
you get
cards.
3x minus
So you
1.
do it
You
99.
get 4x minus 5.
Right.
5x minus
And I see the
The
pattern.
x is going up by 1.
And these go up by 2. Down by 2, yeah. Okay.
So once you get those patterns, you can just add all those things up. The geometric series, the formula for that. It's not pretty, but we could
But
do
wait,
that.
then we have to go again.
You can't do it. I mean, it's probably
And the property
You have to add these up.
in operation.
You have to go again.
But don't we have to take these and work them together? We have to apply
When you mean put them
we're
through?
not done.
Because there will be 50.
I mean, we have 50.
And then you'll have your 50.
Right. So how do we,
And you'll
is
run
there
them.
another pattern
Right.
after we, so how should we pull these together?
That's what the 50, that's where I am.
Right, exactly. That's where I'm stuck too. I mean, I see this pattern, but then how do we, in what order should we pull these guys together? And do you think it matters that we get rid of the X and we actually use the 100? Or is it better?
what would happen if you did it?
Along those.
Then b plus 1 minus 1. So in other words, it continues that pattern of, oh, you just took c plus 1, tacked it on there. Next time you're going to tack, w plus 1 to tack it on.
Understands the 10.
So that's why the pattern continues. Is see the pattern?
W, we could go J, we could go
A, B, C, D, F, yeah. And,
I got it.
All right.
I hit the one.
Isn't she a great teacher?
She is.
He is too.
You did it. That makes sense now why
Isn't that cool?
why it keeps going, and
Isn't
so
that
then
fun?
why you all of a sudden come up with that.
yeah, 101 because the last number was 100, and 100 plus 1.
1 is 101, and then you subtract out the 1.
So then I guess we could generalize it. If you had any set of numbers, it would just be the product. You'd add 1 to all of them, multiply them all together, and then subtract 1.
So whatever the highest number is, plus 1, factorial minus 1.
No, not. Oh yeah, if they're consecutive.
Yeah.
Yeah. Oh, so you're saying yeah? I was thinking of any set of numbers. You're talking about 1 up to plus.
I think it'd be interesting to do like middle school. You can do 1 through 10, almost like so 1 through 100. See what they can do for 30 years.
Okay, it's fine.
That's why I like to work with A1.
And then O is a problem, but you never have to go all the way down.
Yeah, but I always work with A1, A2, A3.
Yeah, but then you have these subscripts, and then you start putting subscripts on your subscripts, and then it's a disaster.
Do you guys know about the online encyclopedia of integer sequences? You heard of this?
Sure, John. Yeah, that's right there on my favorites list.
Excellent, as it well should be. So check this out. I hope it will be after today. So it's OEIS dot. Is it work?
That if you combine 1 through 6 in any way, you're going to get this answer, and then combine that answer with 7, and now you're one step closer.
Yeah, but it still seems like a long way.
Still a long way, but at least that way you get to kind of reuse your previous steps, and you're more likely to kind of see a pattern of how things build up because you can understand these small numbers better. Yeah.
All right.
What did you type in?
I typed in the first 4 numbers from our sequence.
Which
So combining 1.
X times y plus 1 plus y.
Yes.
You suppose that the
X was this previous result. Okay. And Y is n plus 1.
Right.
And
So
then
each step is n plus 1 for n, it's n plus 1
right,
factorial
and then
minus
distribute
1.
and simplify.
That's it.
Beautiful. Okay, you have a proof. Now just wait till you see the good proof. There's like a whole nother layer of beauty in this thing. So. In about a minute or two, I'm going to interrupt everybody again. It's even faster growing than exponential, this crazy thing. Yes. Not by a lot, but yes.
Because what we're trying to do is, we have a recursive function. We're trying to see if we can find the explicit function.
Right.
Then we don't have to worry about Excel.
Yes, that's a great idea.
So we're getting stuck.
Right. So you kind of, maybe you can take the first bunch of numbers and try to start sort of looking for a pattern in what you have. Or, yeah, I don't know what else to suggest. Right? That's really, a lot of times finding that formula really is more like a guess and check kind of process. And how do you come up with a good guess? I don't know. You just look at patterns and try things and see what you come up with.
The numbers for the first 5, right?
So a lot of times when you have those first 5 numbers, like the common habit is how much do you add at each step, right? But here it's growing so fast that adding is not going to do the job. So maybe look at how much do you multiply by each step instead of how much do you add. Because if it's exponential, it's like multiplying by the same amount each time, right? So here, what are you multiplying by at each step? And maybe there's some kind of thing happening there. And maybe you can use your Excel to help you quickly generate a list of those to look at too, right? Okay, so here comes your next interruption. Sorry, folks. I would love to have, 6 hours to work on this problem, but you got to do what you got to do.